Hey everybody, in this video we will be solving the rational equation you see on your screen right now. In this example, we actually have a little bit of factoring to do in the first denominator. Although the factoring is pretty light, it is just a GCF, or greatest common factor, factoring method, but that is necessary to do considering we need to get a closer look at our denominators so we know exactly what the least common denominator is, and then we can multiply through by that. So here, the greatest common factor in this denominator is 6. If I factor the 6 out or divide the 6 out as I multiply it on the outside of the parenthesis, I'll get an x minus 6 on the inside. I'm going to go right here and just cross that out. The 9 is really over a 1, although I don't really recommend that you go through the trouble of writing that. I think that's a little silly. This will be one time that I actually do that. Now I'm going to go ahead and put these giant parentheses around my whole entire problem. Now, I want to multiply through by the least common denominator. Well, what is the least common denominator? Well, everybody needs to have the same factors on bottom. So what is it that we are going to need our denominators to have? Well, we're going to need our denominators to all have a 6, since that first denominator does have a 6 in it. We're also going to need all of our denominators to have the x minus 6. The 1 is not really something that we need to go out of our way to worry about, because obviously it's just the multiplicative identity. So what is the least common denominator? It's going to be 6 times x minus 6. So that is what we will multiply everything by. As long as we do it on both sides of the equal signs, we maintain balance. Totally fine, totally legal. What about our restrictions, which we should try to remember to write down before we go too far? Well, our denominator can't ever be 0 in a fraction. Is it possible for 1 to ever equal 0? No, 1 is a constant. 1 will never equal 0. Is it possible for 6 to ever equal 0? No, of course not. We need to concern ourselves not with constants, but with variables. So here, x minus 6. Well, x minus 6 is not allowed to equal 0, and it's possible it can because x is a variable. I don't know what x is going to be. That means I need to avoid, like the plague, x being equal to 6. So that is my restriction. If that comes up as my answer at the end, it will be an extraneous solution. All right. Anyway, now that we have that all taken care of, our least common denominator is written, our restriction or restrictions are written underneath that, we can go ahead and work on the problem. So I'm going to go through and multiply everything by 6 times x minus 6. So, oh no, can't see. There we go. So I'm going to show this, not every time, but a few times now while we're learning and practicing. I'm going to put a little 6 and an x minus 6 traveling throughout the problem like an interactive little pop-up book or something over here. If I distribute 6 and x minus 6 to this first fraction over here, you'll have x times 6 times x minus 6. What reduces? Well, the 6 and the x minus 6. They both reduce, right? So what is left behind? Just x minus, what if I multiply? I'm distributing it in, right? It's going to everybody. I multiply it now by the 9. What, if anything, will reduce? Nothing. We only have a 1 in the denominator. So we have the 9 times the 6 times, if you want to put the dot, you can, you don't have to, times the x minus 6 equals, it doesn't really line up, but best I could do right now. And now we're going to multiply the least common denominator over here by this fraction. It's 1 times 6 times x minus 6. Well, what reduces or simplifies? The x minus 6. So what does 1 need to multiply by? 1 will only need to multiply by 6. Now, many of you are probably going to not going to write all of this detail, and I don't blame you. You'll maybe write x minus 54 x minus 6 equals 6. Maybe some of you even went so far as to immediately distribute that negative 54 to the inside of your parentheses there. Now, the issue with that is I watch a lot of people mess up when you have a minus sign being distributed into a factor. So please be careful. All right. X minus 54 times x, well, that's just 54x. Negative 54 and negative 6 will become plus. Now, try to refrain from grabbing your calculator. 54 we just saw was 9 times 6, and we're multiplying it by 6. 9 is really 3 times 3, and we still have 6 times 6. So that means we're really concerned with 18 times 18. So if you know your perfect squares by heart, then you can go ahead and just jump right to that. So 18 times 18 is 324. So negative, negative, so that's 324. Hopefully that little technique was helpful. Equals 6. We got to solve for x, so I'll combine these two right over here. Just going to scooch that paper up a bit. We have a negative 53x, and I'm going to subtract 324 from both sides. That was these two combining, right? Equals, so 324 take away 6 would be what? 318. So in the other way, it's just negative 318. Now, a negative on both sides, at this point, I can just cross it out because a negative divided by a negative will be positive. I'm going to divide both sides by 53. However, again, don't reach for your calculator, at least not right away. Try to do this best you can. So what do we know? Well, 318 is even. It's 2 times something. Half of 300 is 150. Half of 18 is 9. So 359, at least to start, right? 53, well, what multiplies to give you 53? Anything good? Perhaps not, but maybe 53 will go evenly into 359. Also, perhaps not. 53, 50, 1, 2, 3, 4, 5, 6, 7. 53 times 7 gets us kind of close to 359. But not so good, right? So it looks like we may not reduce and that our final answer is just 318 over 53. And we could just leave it like that as far as I can tell. So there you have it. It's also not one of our restricted values. So looks like we're in the clear and finished. Whoop. So this reduced down to a 1. So on the side, x equals 318 over 53. It's not 6, so we are good to go. I would always even try to see like, oh, what is 53 times 6? Oh, what did I write over here? 159. Oh, I'm so smart, guys. Whew, good thing I caught that 318. I was like, what? Half of 318. So that's 2 times 159. It does go in even. Oh boy, evenly. 53 goes into that 3 times. I'm so silly. Hey, at least I caught it. So this 50 times 3 is 150. 3 times 3 is 9. So this reduces, right, to a 3. Oh my gosh, and 2 times 3 is 6. And I was just about to say, if I ever got like weird numbers, I would look at my extraneous solution of 6 and go to see, oh my gosh, I'm ridiculous, and go to see like, oh, would this number reduce down to 6? And that's when I noticed like 318 over 53 that I somehow wrote 2 times 359. What am I doing? Sorry, I'll leave it in. Authentic. Yes, so that was a 3 over 1, essentially, and 2 times 3 is 6. Sorry for the mess. Ay, ay, ay. So we just got x equals 6, but what do we know about 6? It's extraneous. It's got to be an extraneous solution. Why? Because we just said at the beginning of the problem that it is restricted. It is a restricted value. It will cause our entire equation to be undefined, and we don't want for that to happen. So yeah, that's a little messy right there. I don't think you need me to necessarily fix that, do you? We made it up to here, 53x equals 318. We divided by 53. We started to break down the numbers a bit. We said, all right, well, 318 is even. It's 2 times what? Half of 300 is 150. Half of 18 is 9. So it's really 2 and 159. Then on bottom, I had a 53, right? 53 was down here. But 50, 50, 50 is 150. 53, 53, 53 is 159. So 159 over 53 reduces to 3 over 1, right? So there's the 3 over 1, and there's the 2 that was lingering, which is a 6, right? So we get x equals 6 when we solve, but it is extraneous since it was an excluded or restricted value. So sorry for the long recap. Sorry for the mistake partway through. Forgive me. I fixed it. Hopefully you're still doing all right. And if you need another example, check the playlist. I promise the ones that come after this have none of that mistake action going on. And just jump around in there if you want to find examples that'll be helpful to you. All right. Have a good day.